Okay, so this is the how we see from we cannot see the difference from outside, but we can see from inside, especially the atom side. Okay, now first of all, a conductor. Why we say a conductor is a conductor from the atomic structure? Because a conductor will have, yes, free electron, or we say in the valence shell got 1 or 2 electron only. So this electron very easy to be emitted out. Agree? What is valence shell? Yes, the last shell of the atom. Okay, Brian, what? Why you and Yun Bin keep talking and didn't listen? So what's the valence shell? 是咩？是啦，对啦。Okay, so we also call the last electron as valence electron. So you can see this one only got 1, so easily to release out. Then this one, insulator. We say this here got how many electron? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 we also call it as octet. Remember? Octa is 8. Octet. So this is very stable. Stable means, well, the electron easily came out? No. So we call it as insulator. We call this as conductor. Then what is semi or semiconductor? So it's half lah. See, this is a silicon. So we got 1, 2, 3. This one can be here. Okay, so we call this is tetravalent. Tetra means 4. Okay, tetra. Thank you. Yeah. Okay, so this is silicon. We normally will make a doping to a silicon. The meaning of doping means we insert some other things inside. So this is original. Means okay, original means one silicon got 4 electrons at the valence shell. So when they put very near each other, this and so for example, here 1, 2, 3, 4. So it will bond with the nearer. It will bond with the nearer other shell to form the octet. I all learn in chemistry. Okay, so next. Then, yes, if we want the shell, the electron starts to flow, we can dope in. We can dope in phosphorus. Phosphorus. Okay, now can you see? Starting here, we got phosphorus. Okay, then what's the characteristic of phosphorus? For phosphorus, we call it as it has pentavalence. What's the meaning of penta? 5. Yes, good. So now if it combined with silicon, now we got 1 extra electron. So you can see every phosphorus will have extra 1 electron. Okay, so when extra 1 electron Okay, then this side, we say it got more electron means it will become N-type semiconductor. N stand for negative, Ken. Okay, so now see. So this is in group 15. Okay, then 15 means got 5 lah. Then you can see, since they got free electron, then the free electron can be moved around. Now, if we want to make this type as p-type, positive type, means we will doping in aluminium, because aluminium only got trivalence. 1, 2, 3 trivalent. So we got extra 1 empty space for electron to float. Get the idea? Okay, so see, continue. So we call this is p-type semiconductor. Okay, so why we use silicon, and yeah, please take it. Take for your friend also. Okay, why we use this semiconductor? Why don't we just use copper? Just use copper. Copper better, what? Always got free electron. No need put the hole, no need care about electron. Okay, yeah, one of the advantage is silicon is lighter. Silicon is thinner and silicon is smaller. So that's why last time our handphone is as big as the water bottle. Right? Show your water bottle. Yes, or bigger like this lah. But now become very slim because of we are using semiconductor. Okay, so now we say here got more negatively charged. We say negative carrier. This part is negative carrier. This one got positive. Hole means it can be a positive charge. Okay, so when we combine, what will happen? We can see the electron can flow in one direction now lah. Okay, so of course, when we draw, we don't draw the whole thing. We just focus on the right-hand side got excess electron, left-hand side got holes. Holes means nothing, but since electron can jump here, can flow here, and we say the hole is a positive carrier, electron as negative carrier. Can get the idea? Okay, so now and we will put a PN junction. Okay, that's later lah. So can you see now the current flows? But you will see, why the negative one come from negative terminal? Because the electron always flows from negative to positive. So on the same time, what flows from positive to negative? Yes, current. Okay. So we say, what is this connection like? Okay, today's lucky number is even number. 34. 开心. What is this connection, or what is this circuit? Forward or reverse bias? Yes, forward bias because the current flows through. So how is reverse bias? Like this. Now, so if you terbalik, this is called reverse bias. So the electron cannot pass through lah. May you describe this connection about reverse bias? Connection. I think we learned last week, right? 不是. Did we learn this? Oh yeah, I haven't teach you yet. Nah, actually it's here. 5.1 shows diode is connected in forward bias. We say anode is connected to positive terminal and cathode is connected to negative terminal of dry cell. So now I want you to tell me how is the connection in reverse bias. Like use number 1 and number 2. Tell me how is the connection of reverse bias. Positive terminal. I mean, I'm asking reverse bias now. Tell me the connection. Repeat. 就是 positive terminal connected to negative to cathode 或者是 to n-type semiconductor. 不用讲 repel， 我只要 connection. Okay, 来 tell me connection. 噔噔噔 22新车 Tell me the connection of reverse bias. How it connects. You must describe it. This is positive. This is n-type, or we say cathode. Cathode of diode is connected to positive. Yes, very good. The word positive terminal of dry cell. Get the idea? If they want you to describe connection, describe in this way, okay? Like, man không ạ? Repeat. Reverse bias, how is the connection? Positive terminal. Connects to cathode of what is this? Connect to diode. Cathode of diode. The whole thing's called diode. This thing called dry cell. Diode actually is the production. You join p-type and n-type semiconductor together. Okay, a diode. Now, what's the function of a diode? Like number 12 lah. Kiranjani. Function of diode. Fast search. I think I told you in the last class. Oh, no. Yeah, I also didn't tell you in last class. Function. I write here function. Okay, Kiran, you sit down first. Call you later. Function is to change AC to DC. Another one, to allow current flows in one direction. 可以吗? Okay, we still got around 10 minutes. Within these 10 minutes, you must be able to recognize the pattern of rectification. Okay, now we skip 156 first. But please do. Hey, I ask you. Never mind. Okay, now look at page 157. This is 157. Okay, we okay, we say the diode is like a valve. Yes, diode is like a valve. So you can see if can you see now the current flows from left to right? So yes, it can flows. It can flows. Current like water lah, okay? Now, if current flows, can you see that? Now, very short only this animation. It flows from right to left. Then the valve will close back. Can get the idea? Now you can see the current flows from right to left. Then it closes. Can get the idea? So now, same thing for the diode. Okay, the AC means current flows in two directions. Okay, I use a blue color to represent one direction. So let's say here is X, here is Y. So the current will flow from X to CRO, then come back to Y. So get the idea? Now, how is current flows in red color? So it will flow from Y back to X. Get the idea? Okay, so it's like left to, like water flowing left to right, then water flowing right to left. So since the valve or the diode just let current flows in one direction, so it will only allow the blue one to flow through. So this is your output. You only can see the blue one. Then now, if the current flows from another side, so it will be blocked. That's why they don't draw the negative current here. Until next cycle starts, blue again. Yes, blue again. Get the idea? Okay, so now we say this current is AC because it got positive direction flows to negative. And then this one from negative flows to positive. Get the idea? Okay, so now what do you think after the output? It will be AC or DC? DC. But still careful. Sure DC ah? Careful. Yeah, correct lah. Correct lah. Because now only got positive part, even though curve only got positive part. So become direct current already. Direct doesn't mean it must be straight. Direct means it only have positive part, alright? So we call this as, like please write here, this is called half wave rectification. Must remember the name, half wave, very straightforward. Only half wave is remains. Rectification means change from AC to DC. The word rectify already means change AC to DC. Okay? Now I have a question. Like draw here very fast. Small draw here. Okay, like this is AC. Then now your diode, just now diode point to right. Now your diode point to left. How to draw diode? Very easy, right? We draw a parallel line first. Then if it is pointing to left, then you put your tip to left. Get the idea? Like that lah. Okay, so like let's draw in the beginning. The graph should the input should be like this. Got positive, got negative. What do you think after passing through this diode? What is your output voltage?深蓝色还是红色？哪个？你就想拖到11:55，对不对？Okay, actually left red color only lah. Get the idea? 那这边因为这个顺着来啦，它就是只给 positive。顺，它如果这样子，它只给 positive 过罢了。等下，如果它倒反，对，就是给 negative 过罢了。output。哎，什么事？什么？再讲一次。是这样子 ，transmission 的时候用 DC 很耗电。Okay, so you might have question about AC/DC use. I'll explain after this. Now your mission is remember the pattern already. Tiffany, 这边来看，刚刚不是讲它从 X 去 Y 你看现在 X 是蓝色的，过不去，被 block 着了。但是当它回到这里 Y 过去，就可以，所以就有红色那个地方。对。对，那你看这边就蓝色能过，这边就蓝色 block 住，红色能过。Okay? Like now, next 4. Like if you make 4 diode, give me 5 more minutes. What's your next class? Tomorrow. Can I take one whole class? Okay, that's 5 minutes, 5 minutes. So light, pattern. Okay, so now AC, positive and negative. So you can see here got, first of all, the positive, okay, goes through here. And then we got 4 diode here, means it will make the negative one go up to positive. Then again the cycle with, start again the cycle with blue, then go down with red. As long as you arrange the diode in this way, it will get like this right here, full wave rectification. 可以吗？ Full wave rectification. 谢谢大家。还有。Wait. You don't care how. You don't care how. Can. Yes. Can. Whatever. You choose one. Just choose one. Okay. You choose. Don't care first. No time. Now you just need to remember the pattern first, Ken. Okay, I will explain after this. No time. Okay, so okay, so if your current like this, you need to charge 8 hours. So the smart scientist makes like this, you charge 4 hours. But still long, right? So yeah. And the scientists add a capacitor so that can smoothen the current. Function capacitor as current smoother, or we say smoothen the current. So now capacitor is like storage. So it will store the charge. So we say charging, then we discharge. So you can see when the voltage goes down, you still got current now. Okay, so sometimes they draw the wave at the bottom, but sometimes they hide the wave at the bottom. Can see the pattern? Yes. No, okay, you are blind. I'm saying Brian. Yeah, you're blind. Okay, so now in full wave rectification, you will see the pattern like this lah. Okay, so like conclusion, one diode you get half wave no matter upper or lower. 4 diodes you get full wave or up. With capacitor, it will be smoothened. So half becomes smoothened, 4 on full also becomes smoothened. Like page 168, like quite. 168, number 2, answer B. Answer for number 2. Let's look at the arrangement. Tell me A, B, C, D. Like A. Okay, first of all, how many diodes? 4 is half or full? Full. Got capacitor? This is a resistance. Capacitor like this. Parallel line. Got capacitor or not? No. C or D? Is what? How many diode? Yeah, A and B, 1 diode. What's the difference between A and B? Yeah, both also half wave, but B got capacitor. I'll explain how is capacitor now. Pattern can get memorized already. And congratulations. Okay. So class 10, thank you class.